We're now on fast reacting metals. So the previous experiment showed us that not many metals actually react in cold water, but we're going to look at two that do. We're going to start with sodium. Sodium's kept under oil in these bottles because it is such a reactive metal. I've fished some out, and what we've got here is a piece of sodium. Now it is dull, because even though it's in oil, it has reacted. But you can see, if I've got a scalpel, I can slice through the sodium and it is nice and shiny. So it is a metal, but it's soft, the sort of texture of cheese. You can cut through it quite easily, and it is a soft metal. Now we're going to look at sodium reacting in water. And what I've got is a trough of water here, and I'm going to drop the sodium into the water. Now before I do that, I'm going to put some universal indicator into the water. Universal indicator tells me the pH of the water, and you can see that the water is nice and green, which tells me that the water is neutral. And then when I add a small piece of this sodium to the water, we should be able to see what happens. And you've got a table to fill in of what the sodium looked like. It stays on the water, it stays on the surface of the water, and it fizzes around the surface of the water. I don't know if you can see that. You can see it zigzag, the zigzag pattern there of the sodium. I'll put a little bit more in, and it fizzes as well. You can see it whizzing around. And as it whizzes around, it's dissolving in the water, and you can see that the green universal indicator is now a purpley colour because the sodium is dissolved in the water to make an alkali called sodium hydroxide. And I'll explain what the fizzing is when we look at the next metal. So that's sodium in water.